And a B.
Alright, so all we have to do is add the polynomials.
Whoever stops recording.
We did this last section. Truthfully, we did this when we did systems of equations, because when we added one equation to another equation, it's basically this. So all we have to do is put the like terms together. We just put them all together into one big problem, put the matching pieces together. Not really doing. You can do this mentally. That's what I do. The only thing in here really that's new is when they talk about the additive inverse. And that's not something we've done just because we haven't talked about the word. We kind of skip this step. The opposite? Yeah. So if we want to add two things, well, it's really when we want to subtract two things. Minus Alright, so I have this polynomial, and here's a, what is this one called?
Trinomial.
Trinomial with three terms. So I want to subtract one from the other. And we have to distribute that minus all the way through. That's what we've been doing, but when we do it, it has a name, and it's called the additive inverse. So when you distribute your minus through, the thing that you get, this thing, is called the additive inverse. Oh. Because you can add the opposite, and that's what we're doing. This is the opposite that we're adding. So it's called the additive inverse. So it will ask you in a couple of the homework problems to find the additive inverse. All you have to do is distribute a minus all the way through. So you just change the sign of each thing, no matter how many there are. You just change each of the signs. Now this problem wouldn't say find the additive inverse. This one says subtract. So we're going to go ahead and subtract it. But if it said find the additive inverse, we just give them that piece and then you're finished. You're just naming it. You don't have to use it. So 2x to the third doesn't have a match, so I'm just going to write it down. 4x to the second, take away 4x to the second, leaves how many x to the second? 0. 0. So what will I write?
Nothing.
Nothing. It is a common mistake to want to put a 1 right there. I don't know why people seem to think they need a placeholder. I don't know, I'm just bringing it up just in case. Because when you divide 4x to the second divided by 4x to the second, that's 1. But when you subtract them, they just go away. So negative 6x and negative 7x makes negative 13x. And then 1 minus 8 makes negative 7. So we subtract it.
So is that the additive?
The additive inverse is this.
Okay.
If they want you to find the additive inverse, they're just going to give you some little polynomial. I appreciate that at least you are whispering now.
It was extremely important. Very important. Very important.
They were talking about who the next bachelor was going to be.
What? No.
Alright, let's find the additive inverse.
That's what you were talking about.
We have really degenerated. I think we're going to make a general classroom rule. If John Clark is the one that said it, I think we can rest assured, no, that's not what they were really talking about.
I resent that.
If you got your info
I totally
from
resent
John
that.
Clark, let's investigate before we accept it.
So am I going to become the boy who cried wolf, and when I actually say something intelligible, you guys will disregard it?
Yeah, disregard it. I mean, we need to investigate before we accept it.
Okay.
Investigate. Blindly accepting it. Alright, we have 6x to the fourth minus 2x to the second plus 9, and we want to find this additive inverse. This is going to be super easy, because all I do is change the sign of everything. And that's the answer, and we're finished.
Isn't that kind of like absolute value?
But it's still recording?
Yeah. Absolute value doesn't change all the signs, it turns everything positive. So it might leave the sign alone. Like absolute value of a positive is still a positive. Additive inverse is just the opposite of it. So, this will be the one I get the most questions about, despite the fact this is the easiest thing on there. Because somehow when it gets real easy, everybody goes, oh, I must have not done that right.
Yeah.
When you get to these questions, yes, you did, just change the signs, that's all you have to do.
Oh, you have to just change the signs?
Yes.
Oh my
She
God.
just does that.
In fact, let's find the additive inverse of something even easier. What's the additive
Negative
inverse?
64.
Negative
Yay!
64.
It's that simple.
Is that all we're learning?
The additive inverse of negative 32 is positive 32. So all we have to do, now if there's more than one term, we have to change all of their signs. But that's all there is to it when they ask you to find the additive inverse. And the reason they're teaching you that is so that when we do the subtraction problems, like we did here, you'll remember to put that negative all the way through. So it's really not, by itself, it's not a skill that you use, like it's not something we do alone. That's an intermediate step to doing these problems, but we were already doing these problems before we learned about additive inverse. So it's a little bit backwards, and that makes it confusing. But it's just a trick to help you remember to put your negative all the way through. So, here's Mrs. Taylor's warning for doing an awesome job on this assignment. Number one, write neatly, because x to the second starts to look like x to the third if you don't take your time and write it neatly. And then, I have another tip, and I already lost it. Don't forget to put the negative all the way through, because it's easy to forget one of those terms. So go back and check that. If you get a wrong answer, go back and check your negative one all the way through. The assignment is
Sweet.
page 212, 1 through 31 odd. Isn't that very straightforward?
Very.
Hold on, I'm getting
1 through 31 on. Yeah. I'm actually recording it with YouTube now. I'm just recording it on the YouTube app.
You do not, let me say this, because you have a valid point.